Okay, good afternoon once again. So we are going to solve the first numerical related to our specific energy. This is our first numerical. Kindly write down the numerical, okay? A rectangular channel of 4 meter wide. The width of the channel is given 4 meter. Carries a discharge of 15 meter cube per second. 15, okay? It's 15 meter cube per second discharge and has a specific energy of 2.5 meter of water. Specific energy is given 2.5 meter of water. Determine the alternate depth. Determine the alternate depth and corresponding Froude number for this flow. Okay. Determine the alternate depth and corresponding Froude number for this flow, and also find the critical depth, and the critical slope YC. If the Manning's n is given 0.02. Okay. So you write down the first the numeric, then we will move on to the solution. Okay. Over a rectangular channel of 4 meter wide carries a discharge of 15 meter cube per second and has its specific energy of 2.5 meter of water. Okay. Determine the alternate depth and corresponding Froude number for this flow, and also find the critical depth and the critical slope if Manning's n is equal to 0.02. So this is the numerical. So before solving this numerical, if you remember that specific energy curve, okay, so this is at an angle of 45 degree. It's E is equal to Y. Okay. In x-axis we have energy, that is your specific energy, and y-axis is equal to depth of flow. Okay. Then for any particular discharge, if you draw a specific energy curve, it will be in this form. Okay, for a particular discharge. Okay. So for any energy apart from your YC, so this is your critical depth, sorry, this is your critical energy, or you can say E minimum, specific energy minimum for that particular discharge. Okay, and corresponding to that particular E minimum, the depth is called YC. Okay, apart from this, if you consider any value of energy, that is here is given 2 meter, 2.5 meter. So if we consider the 2.5 meter energy, draw a line, it will intersect the whole curve into 2 points. One is here. So for that particular energy, you'll be having two depth of flow. Okay, for that particular energy, you'll be having two depth of flow. Okay, so these two depth are called alternate depth. One you consider y1, another one you consider y2. So both the depth, your specific energy is same. So this is called your alternate depth. Okay. So we need to determine these two alternate depth. Okay. That y1 and y2 we need to calculate. Okay. So what is given? The discharge is given is 15 meter cube per second. Okay. Then our specific energy is given 2.5 meter of water. For this particular specific energy, we need to find out the alternate depth. What are the two depths for which your specific energy is same? Okay. Then width of the channel, or they have said that the channel is a rectangular channel. Width of the channel is given, that is 4 meter. Okay. So this is your first part of the question. You need to find out this y1 and y2, and at the same time, if you remember the Froude number, we have already discussed. Okay, Froude number is dy root over gd. Okay, or for rectangular channel, you can directly write vy root over gy. Okay, so that thing we have already discussed. Okay, so for each depth, what will be the Froude number? For y1, what will be the Froude number? For y2, what will be the Froude number? We need to calculate. Okay, first we need to find out the y1 and y2. And if you remember, if this is your critical point or a minimum energy, and then if you draw a line, it divides into two half. One is in supercritical and one is subcritical. Okay, so this supercritical, the Froude number is greater than 1. So these things we have already discussed. Okay, and for subcritical, your Froude number is less than 1. Okay, and for critical flow, your Froude number is equal to 1. For YC, your Froude number is equal to 1. Okay, so now what we have to do, we have to find out this y1 and y2 value for which your energy is same. Then we need to find out the Froude number for both the depth. Okay, and see, your y1 will be in supercritical and y2 will be in subcritical. Okay, so definitely when you find out the Froude number for supercritical, that means for y1 value, that should be greater than 1. Okay, and for subcritical, that y Froude number for y2 value should be less than 1. Okay, okay. So this depth of flow 4 meter is given, discharge is given, specific energy is also given. Y1 we need to calculate, y2 also we need to calculate. Then we have critical depth. That is the second part of the question. Okay, so this also we are going to discuss. First, we are going to find out the y1 and y2 value, and then we are going to find out the Froude number for each depth. Okay, so first we consider this specific energy equation. Okay, so we all know specific energy. We will consider only two terms. One is your depth of flow, and the one is your v square by 2g. Okay, kinetic energy head, v square by 2g. The specific energy is already given, that is 2.5. Okay, this is y plus, for v square we can replace v by V is equal to Q by A. Okay, so it will be Q square divided by twice G A square. Okay, so now the discharge is given, that is your 15 meter cube per second. Okay, for area is for rectangular channel is B by B multiplied by Y. Okay, so B value is given. So this again you can write 2.5 is equal to Y plus 15 square, as your discharge value is given. 2 into G is nothing but 9.81 multiplied by width of the channel. I think it's 4 meter, 4 square, because area is B into Y. Okay, area is B into Y. Okay, you can see this equation. This is 2.5 plus Y plus 15 square divided by twice G multiplied by area. Area is B into Y. B value is given 4 multiplied by Y whole square. Okay, so definitely you have one equation. If you see this equation, you have only one unknown, that is your Y value. Okay, so you just try to solve. It depends on you how you are going to solve this equation. There are various methods, or you can directly use your calculator also to solve this equation. Okay, so if you break again, you can take LCM. That is 4 square is 32, and then 15 15 you can again 225. Okay, 16 to the 32. Okay, okay, then again you do the LCM and then you cross multiply, and we will come up with a quadratic equation. Okay, you see you will get a quadratic equation. Okay, so for solve that quadratic equation and find out the Y value. Okay, you can use your calculator also. One is your 0.62 and one is your 2.37. You find out this. So you're getting the same value. You all are getting the same value, that 2.37 and 0.62. Okay. So once you now for that 2.5 meter, for specific energy 2.5 meter of water, you'll be getting two value, two y value. Okay, one is y1 and one is y2. Okay, and then we will be having another depth, that is our called critical depth for E minimum. So now see, from this how you are going to say which depth is lies on supercritical. Okay, so you see that smaller depth is in supercritical. This is super. Smaller depth is in super and the larger depth in subcritical. Okay, or you can find out the yc value. We have already discussed for yc, that q square by g to the power 1 by 3 for rectangular channel. Okay, you can directly use this equation, find out the yc value. If that y value is less than yc, then we can say it's in supercritical. If that y value is greater than yc, then you can say that depth is in subcritical flow. Okay, so once you find out this two depth, you can find out the Froude number. Okay, so from here we can say this is in subcritical and this is in supercritical. Okay, so for subcritical, your Froude number, when your depth of flow is more, your Froude number will be less. Okay, when your depth of flow is less, your Froude number will be more. Fr is greater than 1 for supercritical. Okay, and for critical depth, your Fr is equal to 1. For critical depth, your Fr is equal to 1. Okay, Froude number. So our first objective is completed, to find out the alternate depth. Okay, alternate depth are the depths for which your specific energy is same. Okay, so now we have to find out the Froude number for each depth. Okay, so we know that Froude number equation is nothing but Vy root over Gd. Okay, d is nothing but d is nothing but a by top width. Okay, so for as we are considering rectangular channel, for area is b into y, and for top width of a rectangular channel we can directly write b. Okay, so this will be cancelled out, y is equal to y. Okay, so in place of d for a rectangular channel we can directly substitute y. Okay, so this will be vy over gy. Okay, so now if we want to find out the Froude number for your subcritical flow, so in place of this y we are going to substitute 2.37. Okay, and velocity, we don't have velocity, so in place of velocity we write q by area. This is given 15, area again b multiplied by y, that y will be again this 2.37 if we are going to find out the Froude number for this depth. Okay, this y value is nothing but 2.37. So likewise you can find out the Froude number. Okay, so this is this Froude number will be in subcritical, so definitely it should be less than 1. Okay, so you see, first you find out the Froude number and you check it is less than 1 or not. Okay, so try to calculate the Froude number. You say for the depth of 2.37, for the depth of 2.37, that we can consider its y2 value because it is in subcritical, and the fraud number for this particular depth you are going to get 0.33, which is less than 1. Okay, so you check and see if you are getting the same value or not. So from the fraud number also you can justify your result that it is in subcritical or supercritical. As for critical flow, your fraud number is equal to 1. Okay, for supercritical, your fraud number is greater than 1. Okay, and for subcritical, your fraud number is less than 1. This is for YC, critical depth of flow. This is for depth of flow less than YC. Okay, and this is for depth of flow greater than YC. Okay, so this is in critical flow. This is your supercritical, and this is your subcritical. Okay, now you see your fraud number, if it is less than 1, then you can say that flow is a subcritical flow. Okay, if you see that fraud number we got is 0.33, which is definitely less than 1, so you can say that the flow condition is subcritical. So similarly you try to find out for y1 also. Okay, that is 0.1861. You try to find out for the next depth also. Okay, and find out how much you got your fraud number. How much you got? Round number for the next depth. For depth of flow 0.62, you will get around 2.45. Okay, 2.45. Yes, yes, correct. Okay, so definitely it's greater than 1. So you can say this flow is in subcritical. Sorry, it is in supercritical. Sorry, greater than 1, so it is in supercritical. Okay, so if you can see here, when your depth of flow is small, then you have high Froude number. That is, your Froude number is inversely proportional to your depth of flow. Okay, if your depth of flow is small, then this will be big, or this will be more. Okay, if this is small, and vice versa. Okay, so you think like this: when there is a supercritical, your depth of flow is less than critical flow, and when your depth of flow is less, then your Froude number is more or increase. So for supercritical, your Froude number is always greater than 1, and for subcritical, your Froude number is always less than 1. Okay. The first part of the question is over. Okay, then the second part, again we need to find out the critical depth. So I think we have already discussed this equation. Yc is equal to, as we are discussing about rectangular channel, q square by g to the power 1 by 3. Okay, to the power 1 by 3. Okay, so q is not given, so in place of q you can write discharge divided by width of the channel. Okay, so square, then it will be also square. Okay, so find out the q square, substitute here. G is 9.81 to the power 1 by 3. Okay, and you can find out the yc value. You see, you are getting the same value or not. 1.127 meter. Over. So your critical depth will be 1.127. Okay, so now the last part, we need to find out the critical slope. Okay, so Manning's n is given, so we are going to use Manning's equation. B is equal to 1 by n r to the power 2 by 3. So sb to the power half, in place sb we will consider critical slope to the power half. Okay, the expression is same. So here n value is already given. Okay, a slope we need to determine. Velocity we can write q by a in place of velocity. Okay, 1 by n r to the power 2 by 3 and sc to the power half. So we need to find out the critical slope. Okay, so if you simplify, you will get this expression. You will get this expression. Sc is equal to is v multiplied by n, small n, that is the roughness coefficient, divided by r to the power 2 by 3 whole square. Okay, because this is to the power half, so it will, if you bring on this side, it will be square. Okay, so area, again we are finding critical slope, so area equal to b multiplied by yc. Okay, or you can say we can use or consider that critical area. Okay, b multiplied by yc. Yc we have already calculated, and b value is given. Okay, so from velocity you can directly find out discharge by area. Okay, discharge is 15. Okay, and yc value is already we have calculated, so you can directly find out the velocity from here. Substitute here, n value is given, r is again a by p. Okay, area we have already calculated, that is b multiplied by yc, and for weighted perimeter it will be twice yc plus b. Okay, so yc we have already calculated, multiplied by 2 plus b is given 4 meter. You will get the weighted perimeter. Then you substitute here area and weighted perimeter, find out the r value, substitute here, and you can directly find out the yc value. See you are getting the same value or not. Okay, so you are getting the same value. Okay, so this is how you can solve your, you can calculate the alternate depth for a particular specific energy, and then you can find out the Froude number, then you can find out the critical depth along with the critical slope. Okay, so we are going to end this meeting here. If you have any doubts you can ask me, or in the next class we are going to solve some more numericals related to specific energy. Okay, so if you have any doubts regarding this, because this is the basic things, if you understand this part, then this unit is clear to you. Okay, then you can solve any numericals related to your specific energy. Only you need to understand this graph, then you can relate everything. Okay, so if you have any doubts then we can discuss, otherwise we are going to end this meeting here.